Pluto has always intrigued astronomers and stargazers, especially given its unpredictable orbit and distant position in our solar system. Once considered the ninth planet, it was reclassified as a dwarf planet due to its unusual and elongated orbit. Despite its demotion, Pluto continues to capture the imagination of the scientific community and space enthusiasts alike. Recent reports have raised concerns about Pluto's orbit crossing that of Neptune, sparking discussions among notable figures like Neil deGrasse Tyson and Michio Kaku about the potential risks this might pose, including a possible collision between the two celestial bodies. So, how did Pluto end up on a path that intersects Neptune's orbit, and what could the consequences be for Earth? Let's delve into this cosmic mystery. Pluto's orbit around the Sun is remarkable due to its elongated, oval shape, unlike the nearly circular orbits of the major planets. Its orbit is also tilted by about 17 degrees compared to the plane of the other planets, adding another layer of complexity to its motion. For nearly 20 years during each orbit, Pluto comes closer to the Sun than Neptune, challenging the conventional understanding of their positions in the solar system. While this may seem alarming, scientists have discovered that the two planets' orbits are not in danger of colliding. In fact, due to the gravitational pull of other planets, particularly Neptune, their paths remain stable. This stability is explained through the concept of orbital resonance, which prevents Pluto and Neptune from ever crashing into each other. The libration effect ensures that when Pluto crosses Neptune's orbit, it does so at an angle, keeping a safe distance. Additionally, the VZK oscillation explains why Pluto's orbit remains stable despite its seemingly chaotic path. Despite these stabilizing forces, the ongoing study of Pluto's orbit is crucial. Observational advancements and computer simulations allow astronomers to model the intricate interactions between Pluto, Neptune, and the Sun. These simulations highlight how even tiny changes in Pluto's speed or position can have profound long-term effects on its orbit. While the risk of a collision remains low, the fact that Pluto's orbit is unpredictable over billions of years makes it a fascinating subject of study. The dynamic and often chaotic nature of space is evident in Pluto's orbit, serving as a reminder of how gravity, eccentric orbits, and celestial interactions shape our solar system. While the possibility of a catastrophic event involving Pluto and Neptune is unlikely, continuing to monitor and study their orbits helps astronomers better understand the larger workings of our solar system and the forces at play in the cosmos. The orbit of Pluto is quite unique compared to other planets. It is more oval-shaped, meaning it doesn't form a perfect circle. In fact, at times it even comes closer to the Sun than Neptune. This creates an interesting scenario because Neptune, too, follows its own path through space. While it seems like there's a small chance that Pluto and Neptune could eventually collide, Pluto's orbit is generally stable and keeps them at a safe distance. This is due to gravitational forces, which pull objects towards one another. Despite the seemingly chaotic paths, Pluto and Neptune's orbits are intricately balanced, maintained by the pull of gravity. Pluto's unusual orbit highlights that space is full of surprises. What may appear to be a chaotic system may, in fact, be a delicate balance of forces. By studying Pluto's orbit, scientists gain valuable insights into the mechanics of our solar system. Ongoing observation and research are vital for expanding our knowledge of the universe and understanding our place within it. Now imagine if Pluto and Neptune did collide. It would be a monumental event that could radically alter our understanding of the solar system. While we've made great strides in understanding space, this situation shows that there's still much to learn. Observing how large planets influence Pluto's orbit gives us important clues about how the entire solar system operates. The position and motion of one planet can affect the trajectory of others, demonstrating the intricate interconnections in space. Despite the odds, some scientists are concerned that Pluto and Neptune could collide. This possibility raises questions about why such an event might happen. Although a collision may seem unlikely, renowned astrophysicist Neil deGrasse Tyson has intriguing thoughts on Pluto. He suggests that renaming Pluto as a dwarf planet is a step in the right direction, emphasizing that we're still learning about how things move in space. Tyson believes that Pluto's erratic orbit serves as a reminder of how much we still don't understand. It's these mysteries that make space so fascinating. Tyson works alongside other researchers to raise awareness about the potential dangers of Pluto's unusual orbit. He worries that Pluto might one day collide with Neptune, causing significant disruptions in our solar system. An impact between the two would release an enormous amount of energy, potentially sending debris flying through space, which could collide with other planets and moons. Neptune itself could be affected, altering its orbit. Famous theoretical physicist Michio Kaku shares Tyson's concerns. Kaku stresses the importance of closely monitoring Pluto's orbit and conducting simulations to understand the possible outcomes of a collision. He warns that such an event could have consequences far beyond our immediate solar system. The gravitational disturbances caused by a Pluto-Neptune impact could ripple outward, affecting the outer planets and potentially destabilizing the delicate gravitational balance of our solar system. Kaku's perspective underscores the interconnectedness of celestial bodies and the need for continuous research and observation to stay ahead of potential threats. While the chances of a catastrophic event are low, it serves as a reminder of space's inherent unpredictability. The universe is full of surprises, and we must remain vigilant in our quest to understand and navigate its complexities. This brings us to an important question. In light of the unlikely yet possible scenario of a Pluto-Neptune collision, what steps are being taken by researchers and space agencies to prepare for such an event? Addressing the potential impact between Pluto and Neptune requires a multifaceted approach that combines observation, simulation, collaboration, and public awareness. Here are some of the strategies being employed. Enhanced observation networks. Observatories around the world, along with space-based telescopes like the Hubble Space Telescope, are constantly monitoring the movements of celestial bodies, including Pluto and Neptune. These observations provide crucial data to refine our understanding of their orbits and predict their future positions with greater accuracy. Advanced simulations. Researchers use powerful computers to run simulations that model the gravitational interactions between Pluto, Neptune, and other bodies in the solar system. These simulations help forecast the long-term stability of their orbits and identify potential collision scenarios. Collaborative efforts. Global cooperation among space agencies, research institutions, and universities strengthens our collective ability to track and study these celestial bodies. By sharing data and expertise across borders, we can take a more comprehensive approach to understanding and mitigating potential risks. Public awareness and education. Engaging the public and raising awareness about the complexities of our solar system is crucial. Scientists like Neil deGrasse Tyson and Michio Kaku play a vital role in communicating these issues to a wider audience, fostering a greater appreciation for space science and the importance of ongoing research. Developing contingency plans. While the likelihood of a Pluto-Neptune collision is low, it's important to have contingency plans in place. This involves studying the potential consequences of such an event on Earth and other planets, as well as developing strategies to mitigate any negative effects. Exploring further missions. Missions like NASA's New Horizons, which provided incredible close-up images of Pluto, are essential for gathering detailed information about distant celestial bodies. Future missions could focus on exploring the outer reaches of our solar system to gather more data and improve our understanding of their dynamics. In conclusion, while the potential collision between Pluto and Neptune presents an interesting and complex scenario, scientists are actively engaged in monitoring, researching, and preparing for any possibilities. Through advanced technology, global collaboration, and public engagement, we can deepen our understanding of the universe and ensure that we are well prepared to navigate its uncertainties.